Alright, in this video we will work a limit at infinity example that students tend to find a little bit more on the difficult side. As with any limit, we're going to try to plug in this value and see what happens. We have to be really careful with infinities. We're going to focus on the highest powers, so we get infinity over infinity. In fact, as a sort of quick and dirty technique that will reliably produce the answer most of the time, we can actually sort of fast track this exercise to get a feel for what ought to happen. Sometimes that's enough actually to just answer the question, but this video will actually have the proper steps as well. So this is the quick and dirty. So you're going to focus on the highest degree term in the numerator. So in this case, that's 6x squared. And you're going to focus on the highest powered term in the denominator, keeping the square root involved. So we have the square root of 4x to the fourth. And then we simplify from here. So the square root of 4 is 2. The square root of x to the fourth is x squared. And here the x squareds cancel. And we get 6 over 2 is 3. So at the very least, we should expect this limit to have a finite value when we're all done. In fact, we will find out that the limit is, in fact, 3. Again, this quick and dirty does not always work reliably. It tends to be a little bit too sloppy when negatives are involved or when the radicals are not so clean. So let's do this the prim and proper way. Our technique is going to be to factor out the highest power of x in the numerator and the highest power of x in the denominator. The numerator is already cleaned up and factored. Nothing really to do there with the numerator. The denominator, on the other hand, has quite a bit of excitement. So I'm going to pull out the x to the fourth. This is of course all inside the radical. And I'm going to look at what's left behind. A 4 is left behind in the first term. In the middle term, we get 3x over x to the fourth, and the last term we get 1 over x to the fourth. We're going to simplify this a bit. So this x cancels one of those, leaving behind 3. And because everything here is positive, this allows us to break up the square root as well. So we're going to get the limit as x goes to infinity of 6x squared over the square root of x to the fourth times the square root of 4 plus 3 over x cubed plus 1 over x to the fourth. Now again, this breaking of the radical is legal because both factors back here are non-negative. When negatives are involved, you do have to be more careful. Okay, so the square root of x to the fourth is x squared, which we saw in the quick and dirty work. And now this is going to be the limit as x goes to infinity of 6x squared over x squared times the square root of 4 plus 3 over x cubed plus 1 over x to the fourth. Now the x squareds cancel, and we get the limit as x goes to infinity of 6 over the square root of 4 plus 3 over x cubed plus 1 over x to the fourth. Now we can evaluate the limit at infinity. The sharing 3 things with infinitely many people gives us all nothing. Sharing 1 thing with infinitely many people gives us all nothing. And we get 6 over the square root of 4, which we saw before is 3. Now we will try a trickier example of a limit at infinity. We'll do the limit as x goes to negative infinity. That's usually one of the telltale signs that you should be watching out when you see that x going to negative infinity and a radical involved. So we'll have 9 times the square root of x to the 6th plus 4x squared plus 1. And in the denominator, we'll have 2x cubed plus 5x squared minus 19x plus 7. Again, as with any limit, we're going to try plugging that in and see what happens. This one is going to be quite strange, but we're going to get infinity over negative infinity. And so we're going to factor out the highest power of x in the numerator and denominator. Now the quick and dirty here will not be as reliable, and we'll find out why after we factor out the highest powers of x very carefully here. So we factor out in the numerator the highest power of x is x to the 6th. So we'll factor out x to the 6th and we get 1 plus 4x squared over x to the 6th plus 1 over x to the 6th. And in the denominator, we'll factor out x cubed, which is the highest power down there, leaving behind a 2 plus 5x squared over x cubed minus 19x over x cubed plus 7 over x cubed. Now we'll simplify all the powers of x. Here we have the limit as x goes to negative infinity of 9 square root of x to the 6th times 1 plus 4 over x to the 4th plus 1 over x to the 6th. And in the denominator, x cubed times 2 plus 5 over x minus 19 over x squared plus 7 over x cubed. Now we have to take a little side trip here. The square root of x to the 6th is equal to x cubed if x is positive, but square root of x to the 6th is actually equal to negative x cubed if x is negative. Typically, what you'll see in a text is the reminder that the square root of something like x to the 6th is equal to the absolute value of x cubed. And then they don't have to consider the cases of positive or negative. Now here we have x is going to negative infinity. So we in fact have this negative x cubed is what comes out of that square root. So we have the limit as x goes to negative infinity of negative 9x cubed times 1 plus 4 over x to the 4th plus 1 over x to the 6th. All of that is divided by x cubed times 2 plus 5 over x minus 19 over x squared plus 7 over x cubed. The x cubes cancel, and let's just remember here that this was positive, this is now negative. That is a non-trivial issue that has surfaced in this example. So this is going to be the limit as x goes to negative infinity of negative 9 times the square root of 1 plus 4 over x to the 4th plus 1 over x to the 6th. All of that is over 2 plus 5 over x minus 19 over x squared plus 7 over x cubed. So now when we try to share 4 things with infinitely many people, we get 0. 1 thing with infinitely many people, 0. 5 things with everybody, nothing, and we get nothing. 19 things with everybody, we get nothing. 7 things with everybody, we get nothing. When the dust settles, we have negative 9 times the square root of 1 over 2, which is negative 9 halves. Now, had we done the quick and dirty, naively, we would have gotten positive 9 halves. You can modify the quick and dirty so that you incorporate this fact up here. and that will save you and get you many more of the cases for the quick and dirty method.